Well, greetings, Chem Department. Today we're going to look at how much heat energy does water absorb or release while on a hot plate. So to begin with, we're going to start out. We've got thermometer in our initial water showing that it's at about 18.6 degrees Celsius. Now we're going to take some of that water . 54.7 degrees, or 54.7 grams, and we're going to place it on the hot plate. So what we're going to be looking at is, during this time, the hot plate on high is going to begin to heat up that water. So we're going to look at our equation now for the specific heat, or the energy. Q is equal to mc delta T. So to start us off, on the side we've got our Q standing for heat, measured in the unit joules. Mass in grams. C, or specific heat with the unusual unit joules per gram degrees Celsius. And then our key unusual one, temperature, or change in temperature, delta T, is going to be the final temperature minus the initial temperature. Now what we knew right away was initial temperature of our substance was 18.6 degrees Celsius. And we took the mass down of our material to be 54.77 grams. So what we're going to be looking for is solving for our equation Q is equal to. Now, the other substance we know right away, or the other information, C, is going to be the specific heat of a substance. Specific heat of water, 4.184 joules per gram degrees Celsius. So just to write that out, our Q is equal to our mass, 54.77 grams, times that specific heat. That's that known quantity that's given to us. And now for our final part, that temperature, we're going to go ahead, and it started to boil now. We're at a temperature of about 98.5 degrees Celsius. So our final temperature, 98.5 degrees Celsius, minus that initial temperature, 18.6 degrees Celsius. So if we were to do some calculations, that first one we want to look at, that 98.5 degrees Celsius minus that 18.6, we have a temperature change of 79.9 degrees Celsius. Note that that's a positive number. So if we were to take that and multiply by our mass, and multiply by our specific heat, we get a total of 18,300 units. Grams will cancel grams, degrees Celsius will cancel degrees Celsius, and we're left with the unit joules. Now notice with this answer, it is a positive number. If Q is positive, energy is being absorbed during this time. If Q is negative, energy would be released. So our next step is to look at, if we remove that water from the hot plate and let it just sit on the side, how much energy would it release? But right now, with that Q being positive, it shows that energy was absorbed, and then specifically how much energy was absorbed during this time. Safe travels to everybody. All right, so now what we've done is let the water that was on the hot plate sit on the table for a couple minutes. So now if we look down, The temperature in the water was 98.5 degrees. It is now 48.7 degrees Celsius. So looking at that, when we removed the water from the hot plate, it began to change temperatures. The mass has stayed the same. The specific heat of water is still the same. But now the initial temperature was the temperature of the water that we ended with. And now our new final temperature was that 48.7 degrees Celsius. So we can take that new temperature, that final minus the initial, now that new temperature, that 48.7 degrees Celsius, subtracted from that 98.5 degrees Celsius, we come up with a negative 49.8 degrees Celsius. So that change in temperature now, when we plug that in, that 54.77 grams times that 4.184 joules per gram degrees Celsius multiplied by that negative 49 is now going to come up with our answer Q. Grams cancel grams, degrees Celsius cancels our degrees Celsius, and we are left with negative . Now the key is that negative number, because the temperature final was less than the temperature initial, shows that during this time energy is released. So as we're working going forward, it's key to look at that Q value. Is Q value a negative number showing that it's being released, or is Q value a positive number showing heat is being absorbed? Safe travels for everyone. Talk to you soon.